Hello, welcome to Bits and Bytes. In this episode, we're going to see how to save programs on cassette or disk, and also how to use the computer to help you keep track of things, to organize, sort, and manipulate information in various ways. In other words, we're going to see how the computer can provide you with a very efficient filing system. In our last episode, Billy Van wrote a short program of his own, but when he turned the computer off, that program was lost.
Aha! No, it wasn't. Just a moment, please. What I actually did was, before I turned the computer off, I copied my program in the back of this envelope. And now I've just finished retyping it back into the computer.
Well, that's very clever, but there's a better way of doing that.
Well, maybe so, but just let me see if this works, okay?
Mm-hmm.
When was Canada born? Terrific. Okay, now an early date. Early. Okay, 1958. Late. Now, 1867. Very good. You see, it does work. But what's your better way?
It's one in which you don't have to write your programs on the back of an old envelope.
Well, what am I going to write them down on?
There's a blank cassette on the table beside you. You could write your programs on that.
Well, I don't think there'd be enough room to write it all in here.
No, not like that. Remember, computer cassettes are just like ordinary audio cassettes. You can both play back and record on them, can't you?
Yeah, that's right, of course. I could put my program on cassette. Why didn't I think of that? It's just like my recorder at home.
Okay. Put the blank cassette in the recorder.
Okay.
Type save, but don't press return just yet.
Okay.
To start the recording, press record play on the recorder, then press return.
Record, play, return.
And in a few seconds, the computer will beep at you to tell you that the recording has begun.
Ah, here we go.
And when it's finished recording your program, it'll beep once again.
That was quick.
Well, your program is a very short one, and it is now saved on the cassette. Press stop and rewind the tape to the beginning.
Okay. Rewind.
Now take the cassette out of the recorder and label it.
And label it?
Mm-hmm.
So now you want me to write on it. Works like my toaster at home. Now, I suppose I'll be able to get my program back anytime I choose, huh?
Absolutely. Now when you turn the computer off, you don't have to worry about losing your program. You've got it on tape. Give it a try.
All right. Program gone. Now, in order to get it back into the computer, I put the cassette into the cassette recorder, press play, and type load.
Yes, but first press Control and Reset to tell the computer that you want to use the cassette and not the disk.
Okay. Control, reset, play, and load.
The computer will beep twice to indicate the start and finish of its loading.
Ah, there we go. Now I stop the tape?
Yes. You now have a copy of your program back in the computer. If you want to see it, type list. If you want to run it, type run.
Okay. L-I-S-T. Ah, there it is. And run. R-U-N. When was Canada born? Okay, let's check it out. 1494. Early. 1947. Late. Now we try the real one. 1867. Very good. You know, that's reassuring. So that's how you keep a program on a cassette.
Let's recap that. To copy a program from a cassette into the computer, you press play on the cassette and type load on the computer. To copy a program from the computer onto a cassette, you press record on the cassette and type save on the computer.
And to save a program on a disk, do I put a blank disk into the disk drive and type save?
Yes, but the disk must not be completely blank. It must first have been formatted. And let's have a look at what formatting is all about.
The tape in a cassette is like a very long scroll of parchment. The only way to find a particular piece of information is to read through the whole thing from beginning to end. This is because the information is arranged in one long, uninterrupted sequence. You have sequential access to information on a cassette. But a disc, on the other hand, is like a book. You can go directly to any particular piece of information you want, ignoring all the rest of the book. You have random access to information in a book or on a disc. But before you can read or write information in any particular part of a book, you must first number its pages and give it a table of contents. The same goes for a disc. When it's manufactured, it's completely blank. In order for the computer to find its way around the disc, it needs page numbers and a table of contents. Putting this information on the disc is called formatting, and usually consists of dividing the disc into a number of tracks, like the chapters of a book, and then dividing each of these tracks into a number of sectors, the pages. One or more of these sectors will be set aside for a table of contents, a catalog. Once a disk is formatted, the computer can randomly access any of its sectors in order to read or write some information. That means that when you type save and the name of the program, it's very easy for the computer to save your program on any particular part of the disk. And when you type load and the name of the program, it's equally easy for the computer to load your program from that particular part of the disk back into its memory.
Tell me, do we have a disk for the Apple that already has page numbers and a table of contents?
Yes, you'll find some pre-formatted discs on the rack in front of you.
Oh, okay.
Turn the Apple off. Load the disk, and then turn the computer on again.
Okay, Apple off. Load disk. And Apple on. Shall I type in a program now?
Sure, go ahead.
Okay, let's see. I think I'll use that program that printed my name forever. Now, how did that go? It was one print, quote, Billy, then, quote, return to, go to, one. Now, to save this on a disk, I just type save?
Yes, but you also have to say what you're saving so you can find it on the disk later. You must give your program a name.
Well, it's an endless loop, so I'll just call it loop. Save loop. So this program is now permanently on the disk.
Type catalog and you'll see.
Okay. Ah, hey, that's terrific. You know, I could save all sorts of things on a disk.
Yes, you can keep anything you like. Not just words and numbers, but pictures, music, or whatever. There's an Apple demo disc in the rack.
Oh, yeah, here we are.
It's got quite a long catalog of programs, a lot of variety.
Okay.
Now, type catalog, then return.
Okay.
Press the space bar to see the rest of the catalog. Type Run Color Demo, and that'll load the program from the disk and run it.
Okie doke.
Choose Kaleidoscope. You'll see a pretty picture.
It's number 3. Oh, it is pretty. Look at that. Oh, I love it. Just like a rainbow.
Now press ESC. then number 5 to exit. And if you want some music, type Run Applevision, which is another program in the catalog.
Okay. Hey, that's terrific. It's like they have their own built-in hoedown. How much can you store on one of these disks?
These usually hold about 100,000 bytes or characters. In terms of words on a page, that's the equivalent of a 50-page book. But of course, some of the large disks will hold millions of characters.
You know, you could put an entire encyclopedia on just a handful of these things, like a complete library.
Not only that, but once information is stored electronically on a disk, you can manipulate it much faster than when it's stored in any other form. Perhaps the world's largest electronic filing system for news stories is the one maintained by Canadian Press in Toronto.
Canadian Press is a news agency that started 60-odd years ago. And our job is to collect news from around the world, working with other agencies, and within Canada from our member newspapers. We have several hundred journalists, and they use a number of means to provide that news into our central storage and retrieval system, from teletypes to portable terminals to video display terminals hooked to local computers. That information is then fed over a communications network into our storage system in Toronto. The information is then processed, edited, rewritten by our regional and national news editors, and then redistributed across the country to suit the particular requirements of the daily newspapers. Before we introduced computers into the news agency operation, we kept paper copies of all the news that moved on the wires, and we stored them in file boxes down in the basement. Everything was categorized, but if someone wanted to find an old story, the journalist had to go down and get the paper winder and start rolling through all the news copies. And to go through any substantial amount of background, it would take hours, if not days or weeks. Now that the information is stored electronically, by putting in the appropriate keywords, the journalist can get, in a matter of seconds, access to all the news items that contain those particular keywords that have been passed through Canadian Press since 1974.
A database is nothing more or less than a collection of words, information, numbers in a form whereby a computer is able to retrieve, using various methodologies, the information that's contained. In most databases, say an example would be a database used in a business or a private individual's personal database where you were sorting names, addresses, and phone numbers. You would put that information into certain categories. So let's say if you had the names of all the people who get Christmas cards, you would put the names in a certain field, then you would put the addresses in another field. You obviously then couldn't look for number 200 Yonge Street in the field that was called names, because they wouldn't be in the same place. So that's on a simpler level, how a lot of databases are built. The second level up from that is a keyword search database, where with human intervention, someone sits down, takes the information, and sorts through it and says, here are 3 or 6 or a dozen words that are key indexes. So a story, let's say, on acid rain in southern Ontario, you would index under the word acid, rain, Ontario, southern. Any search on the word acid and rain would find that story. What QL Systems uses, and therefore Newstex, is natural language search. What the system does is it takes the full output of our newswire, which is about 250,000 words a day, and it indexes absolutely every single word. So, for example, along comes the word acid. It takes the word acid and it says, have I ever seen the word acid before? And it looks up its little index where it has the word acid stored, a dictionary. We call it the dictionary. And it says, oh yeah, I've seen that word 23,948 times before. Here's 23,949, and I'm going to store it over there. Then if you say you want to do a search on acid and rain, it finds all of the places that it stored acid, all of the places that it stored rain, does a sort, determines which one of those stories contains both words, and then narrows it down. To retrieve stories, I simply type in the words. Let's take the example of acid, rain, and Bill Davis, the Premier of Ontario. Now what I can do is look for the words that I've searched for to make sure they're in here, and they're easy to see by turning down the brightness on the screen, and there's Davis and there's acid rain. To see the next page, I just hit the return key, and it goes on and shows me the next page. If I keep going, it goes to rank 2, the second story, or I can go directly to, let's say, the oldest story, which is number 24, by just typing 24. And we're now at a story from May 22nd of 1981. The system is really stupid, and the intelligence really has to be on the part of the operator. Professional database systems like this are reasonably expensive. You're paying in the range of $1, $1.50 a minute. So what you want to do is sit down beforehand, decide exactly what you want and how you want to get it, and that way, a typical search, even though you're paying at the rate of, say, $90 an hour to use that database, the typical search might only take you 3 to 5 minutes, in which case the total cost is, say, $10. Now, to retrieve that same information, let's say you had to go to the public library. Well, for a journalist or a researcher or a freelance person who, needs that information, I mean, that's cab fare to the library, let alone lunch and the, 4 to 6 hours of searching and all of the time and effort that's involved. So we're seeing more and more that people in a wide variety of areas, not just journalists, but corporate researchers, people in the public relations field, the university community, are using these databases, and the real trick is understand what you want to get in, find it, and get out.
You know, it would be terrific to have a filing system like this.
Wouldn't it? But you could have a miniature version of something like that in your own home.
I could?
Sure. What would you like to file?
I don't know. Well, my address book.
Mm-hmm.
And I could keep everybody's name alphabetically and... Wait a minute. I almost forgot. My new coins from my collection. Do you think I could keep a record of these on a disk?
Nothing to it. And you could sort the coins by country, date, or value.
Oh, that'd be great. I know what, I could just type a description of each coin and then save the information on a disk.
Well, no, I'm afraid that's not quite how it works.
Why not?
Because here's where you have to make a distinction between programs and data.
Programs and data, well, what's the difference?
Data is the information you want to store, such as the description of each coin in your collection, but you cannot store that ordinary information or data yourself.
Why not?
Well, only a program can tell the computer how to organize and classify that data and where to file each item on a disk. Remember it this way: people save programs, and programs store data.
Well, does that mean I'd have to write a new program now?
You could, but you don't have to, because there are plenty of ready-made filing programs which are very easy to use. The Atari across the counter already has one loaded into it.
File Manager, main menu.
Now, the first thing you'd normally do with a filing program like this is create a form, where in your case, you can fill in the details about your coin collection. To save you time, the form has already been created. Just type 2 to review form.
Okay. Oh, what does field name mean?
A field is the smallest item of information about something. In this case, the country, date, and value of your coins.
And len?
Length. The form has been set up so that your descriptions can be up to 20 characters in length.
And how about index country?
That means that when you fill in the details about your coins, the information will be arranged alphabetically by country.
Oh, that's nice. Now, how do I get going?
Start filling in your form. To do that, you need the record menu. Press the select button twice. And you need item 1, enter record. That just means fill in the information about a coin on the form.
Oh, here we go. Okay, the first one is the USA, and the date is 1964, and the value is 50 cents.
That's it. Now to store that information in the computer, press the Start button.
Oh, okay.
Now the details about your second coin.
All right, it's Great Britain, and the date is 1955, and the value is 6 pence. And the third coin is 1876, 1 cent. And this is a rare one. This one's East Africa, 1952, and the value is 10 cents. Okay, that's it.
Fine. Now press Select to go to the record menu again. Let's check if your coins have been sorted alphabetically by country. Just type 5 to review index.
Okay. Look at that. They're all there. Isn't that terrific?
If you want to check what you've put into the files, go back to the record menu and type 2 and press Start. Keep pressing Start to go to the next entry.
Oh, this is amazing. Hey, would the computer be able to sort my coins by date?
Oh, very easily. Go back to the main menu. At the moment, your coins are indexed by country. Now you want to index them by date. So, type 4 to re-index.
Okay.
Just type L for index length. It's now re-indexing your coins under their dates. Now go back to the record menu and review index.
Okay, that'd be 5. Well, I'll be. That's tremendous. Now they're sorted by date.
And as we've seen at Canadian Press, that is just the beginning of what you can do to sort, classify, and organize data in a good computer filing system.
Well, it's all very impressive, but, you know, there are so many new words here that I'm not used to. Database, file, field, record. Needless to say, it's getting a little confusing.
Oh, I can well imagine. Maybe this short film will help sort things out.
The computer has a special vocabulary when it comes to storing information. First of all, it distinguishes carefully between this, which is called a program, and the information that you give to this program, or the information that this program gives to you, which is called data. The reason that it's called data is because the Latin for given happens to be datum, plural data, to stand for several pieces of given information. When a large collection of data is organized systematically, it is called a database. In other words, a database is a filing system, which contains lots of files, each of which contains lots of records, each of which contains detailed items of information, which are called fields. For example, if you had information about all the students in a school, and all the books, and all the pencils, and if all this information were interrelated in a systematic way, then you could call this a database. And the information about one particular class of students could be called a file. And the information about one particular student could be called a record. And each individual item of information about that student could be called a field. It's like Chinese boxes. A field is contained in a record, and a record is contained in a file, and a file is contained in a database.
So that's really all that a database is, an electronic filing system.
That's all. And you can have your own database if you like, thanks to prepackaged programs like the Atari File Manager. There are similar programs for all the other micros, and they all do the same kind of thing as Atari's.
And now I know not only how to move information from cassette or disk into the computer, but to move the information in the other direction from computer onto cassette or disk.
That's right. And in our next episode, we'll look at modems.
But how can my computer hear this?
See that flat black box beside you?
Uh-huh.
Fit the telephone receiver into the two sockets.
Oh, okay. Phone cord this way, all right?
Now your computer will be able to hear messages and speak into the telephone itself. Mind you, there are different types of black boxes. For example, the Apple next to you. It's already hooked up to one that connects directly with the telephone jack.
Oh, so I don't have to fit a telephone into this one.
No, it bypasses the telephone completely. And various kinds of computer networks.
Ah, my goodness, welcome to the source. Thank you, nice to be here. The source main menu. Okay, let's try item 5, education and career.
You work through menus, each one getting more and more specific.
Well, all right. Mathematics. Okay, general mathematics. The answer is 12. Oh, I thought they were going to give me something hard.
We'll see how to move information between computers.
The simplest way to link computers together is via a network controller and a disk drive. This enables all the computers to load any of the contents of a single disk into their RAM memories.
Until then, I'm Luba Goy for Bits and Bytes.
And I'm Billy Van. Bye for now. Oh, the expensive one.